Welcome everyone, Mr. Miller with a bonus video for you. Today we're going to be looking at triangle proportionality, and I'm going to be doing some problems with you in addition to what we did in the lesson. So let's take a look at number 1. So if AB, this little part right here, is 6, and BC, this little part right here, is 4, and AE, this part right here, is 9, we want to find this part right here, ED. This is our unknown. So I know that these are both parallel to each other. So I can set up AE equals ED, or AE divided by ED equals AB divided by BC. And the reason I can set this up is the triangle proportionality theorem. Now let's fill in what we know. So we know that AE is 9. We don't know what ED is. That's what we're trying to solve for. We know that AB is 6, and we know that BC is 4. So I can cross multiply this, which gives me 36 equals 6 times ED. Divide both sides by 6. I get ED equals 6. So this unknown length right there is going to be 6. Let's take a look at number 3. So we want to determine whether in R is parallel to PQ. That's what we're trying to find out. So to show that in R is parallel to PQ, we have to show that PN divided by NM equals QR divided by RM. So we know what PM is. PM, this whole length right here, that's all going to be 18. PN, this little length right here, that's going to be 6. So again, the whole thing is 18. The little one is 6. I know the whole thing up here, QM, that's going to be 24. And RM, this one right here, is going to be 16. So again, I want to show that PN over NM equals QR over RM. So I'm going to start off with the first one, PN over NM. So PN is going to be 6, because that's what's given. NM is this one right here. Well, that's going to be 18 minus 6. Because if the whole thing is 18, then this part is going to be 6 less than it. So that gives me 6 over 12, which is 1/2. Now let's find the other one, QR. QR over RM. QR, we don't know what that is fully. We know it's 24 minus 16. So 24 minus 16. We know what RM is. That's going to be 16. So 24 minus 16, that's 8 over 16, which is 1/2. So these both equal 1/2. So therefore, line segment in R is going to be parallel to line segment PQ. And this is by the converse of the triangle proportional theorem. Let's take a look at number 5 now. So we have VR, VZ, and ZR are mid-segments of triangle UWY. We want to find the value of X. So with this first one right here, we have that ZR equals 25. We want to find UY. We're not going to do these two, so I'm going to cross them out. So come over here, 5. So using the triangle mid-segment theorem, CR equals 1/2 UY. Again, this is the triangle, mid-segment theorem. So plug in what we know. We know ZR is 25. We're trying to find UY. So this equals 1/2 X. To undo this, I'm going to multiply both sides by 2. So I get 50 equals X. Let's take a look at number 7. With number 7, I have that YW equals 2.7, and I have that ZV equals X. So ZV equals 1/2 YW. Triangle, mid-segment theorem. Plug in what we know. We know what YW is. That's going to be 2.7. So 1/2 times 2.7. We don't know what ZV is. That's our X. So if we take half of 2.7, we end up getting 1.35. Let's take a look at 9. So in Mika's town, K Street and Bay Street are parallel. So these two are parallel to each other. Find the value of X, the distance from K Street to Bay Street along Earl Street. So along here, we want to find this right here. So we're going to use the corollaries to help us out. So we know that this part up here is 1. We know that this part right here is 1.4. We know this part right here is 0.8. So we have that this side over this side, so 1 over 1.4 equals 0.8 over the other side, which is X. Again, this is corollary. .1. Cross multiply. That gives me X equals 1.4 times 0.8. So it's going to be X equals 1.12. So Earl Street is 1.12 kilometers. And then let's take a look at our last bonus example that we're going to do. So we're going to do number 11. So I have these 3 parallel lines cut by these different transversals. So again, because they are parallel lines cut by the transversals, I know that this segment right here equals this segment, and this segment equals this segment. So I'm going to have 2x plus 1 equals x plus 7. And then I'm going to have 3y minus 8 equals y plus 5. So subtract x from both sides. That gives me x plus 1 equals 7 minus 1. I get x equals 6 minus x minus x. So we got x equals 6. For the other one we're solving for, I'm going to subtract y from both sides. That gives me 2y minus 8 equals 5. Now I want to undo this, so add 8 to both sides. That gives me 2y equals 13. Divide by 2. Y equals 6.5. So again, with this one, we saw that this equals this segment equals this segment because 3 parallel lines are cut by the transversal. So these are bonus material for you on top of the lesson that you've already watched in Edpuzzle. So use the Edpuzzle notes and this bonus to help you out with the practice problems.